Let's further our discussion of logarithms. This time we're going to change to log base a. So no more base 10. We're going to change the base to something else. If f of x equals a to the x, the inverse of that, if you're paying attention in the previous video, should sort of make sense that that's going to be log base a of x. Instead of being 10, we have a now. And here is something vitally important. And we used this a little bit in the last section. But in general, if b equals a to the x, that's an equivalent statement to saying that x is equal to log base a of b. Remember what I said, logs are equal to exponents, provided that b is greater than 0. So let's look at graphing log base a. This curve would represent a to the x. A to the 0 is 1, a to the first is a. When we find the inverse, we interchange domain and range. It's a reflection across the line y equals x. There is log base a of x. Instead of having a horizontal asymptote, it has a vertical one. All logarithms have vertical asymptotes. They don't have horizontal asymptotes. So, write an equivalent exponential equation for log base 10 of 1,000 equals 3. What are logs equal to? They're equal to exponents. Base of 10, exponent of 3 equal to 1,000. That's a true statement. Part B, write an equivalent logarithmic equation for 3 to the 4th equals 81. What's the base? The base is 3. So we're going to write log base 3. Remember, logs are equal to exponents. So this log is equal to 4. And what are we taking the log of? 81. You need to be able to move fluidly between these two forms. It's very important for solving equations. So here we go. Log base 2 of 16. We can do this two different ways. Log base 2 of 2 to the 4th. What do you think happens with log base 2 of 2? Cancels out. They undo each other, leaving us with 4. Or another way to look at this is say, okay, this equals x. 2 to the x equals 16. 16 is the same as 2 to the 4th, x equals 4. And let's take that stance on the rest of these. Let's set this equal to y. 5 to the y equals 0.2. 0.2 is the same thing as 1/5. 1/5 is the same as 5 to the negative 1. That means that y has to be negative 1. Let's let this equal z. So 10 to the z equals 100 to the 1/5. 5th root 1/5 power. Okay, so 10 to the z has to equal 10 squared to the 1/5. And 2 times 1/5 is just 2/5. So z would equal 2/5. And finally, let's let this equal d. Just picking different letters here. 2 to the d equals 1 over, let me write this better, 2 to the negative 1/2. The negative flips over this fraction. The 1/2 is the square root. D is negative 1/2. So being able to flow fluidly between exponential form and logarithmic form is a very, very important skill to have. It makes evaluating these logarithms quite easy, and it's something you should be able to do without your calculator, but it's easy enough to check. Log base 2 of, what was that last one? 1 over square root 2. Negative 1/2.